వస్తుంది వచ్చా. Hi students, good evening to one and all. Now welcome back our favorite video channel HGVS. This is B Ramesh Kumar, JL in Maths. Now today, this time we have to discuss the topic pair of straight lines part 9. In previous classes, so many problems and models discussed in our channel. So watch these previous classes and subscribe to my channel first of all and share to your friends. So today this time we have to discuss important standard formulas for quadrilateral formed by given two pairs of straight lines. Here we have to discuss important formulas for quadrilateral. These are quadrilaterals formed with the given two pairs of straight lines. Now here first of all we have to discuss the formulas. So in that quadrilaterals formed by two pair of straight lines, two pairs, that is s equal 0 and s dash equal to 0. Here we have to observe s equal 0 is one pair of straight line, s dash equal 0 is another pair of straight line. Now in that we have to take two pairs. Let it be considered, let s equal to ax square plus 2hxy plus by square equal to 0. This is one pair. Similarly, we have to consider second pair, that is s dash equal to ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. So these are two pairs of straight lines. Now here these two pairs formed a quadrilateral. Quadrilateral means in a polygon there are four sides. So first of all we have to observe this is one pair and this is another pair. So in that we have to observe this is the quadrilateral, that means ABCD. So this is one pair, this is second pair. Now there are two pairs are there. In that one pair is completely passing through the origin. That means the point of intersection of these two lines equals to origin. So here A can be taken as 0, 0. Similarly, we have to observe the second pair. In that second pair, ax square plus 2hxy plus by square, these two are common up to y square terms. The remaining x, y set constant x plus 2fy plus c. Now clearly we have to observe the is does not passing through the origin. The second pair is does not passing through the. Now here that pair is s dash, this is s equal 0, this is s dash equal to 0. Now in that up to y square, ax square plus 2hxy, here up to y square terms are equal. Here the coefficients of x square and xy are equal. In that second pair, extra term, that is 2gx plus 2fy. So clearly we have to observe this is homogeneous. This is a second degree equation. Now here the quadrilateral formed one pair homogeneous second degree equation and another now second equation. Now in the quadrilateral is a rhombus. Here the first condition, that quadrilateral ABCD so here that quadrilateral is two pairs. Here the condition is the first condition. In that a plus b is not 0. That is the first condition. A plus b is 0. That means a plus here in the coefficient of x square plus coefficient of sum of coefficient of x equal to 0. Pair of lines are perpendicular to each other. A plus b equal to 0. These two lines are perpendicular. But in that condition, a plus b is not equal to 0. Therefore, these are does not perpendicular to each other. So, which is less than 90 degrees. Which is less than 90 degrees. And here, the another condition means the condition is b into a minus b into fg into f square minus g square O equals to a g plus h square equal to these two conditions, two pairs of equations, and these two pairs of that is clearly a rhombus. This is the first type of triangle. In that, suppose that ABCD is a square. Is a square. That ABCD, that quadrilateral is a square. That means here also two conditions same. Here a plus b equal to here a plus b equal to 0. Because of in that we have to the any adjacent sides not equals to, that means any pair of not perpendicular to each other. So these are all less than 90 degrees. In the rhombus, angle between any two adjacent sides is less than 90 degrees or greater than 90 degrees. Less than or greater than does not equals to 90 degrees. So, and also here in the square, in this quadrilateral, that is a square. Now a plus b equals 0. That we take any pair that lines is perpendicular to each other. That means we have to observe, see the angle between any two adjacent sides. Any two adjacent sides compulsory. That means in a pair of straight lines clearly that are perpendicular to each other. In a similarly, in that the condition, second condition, a plus h into f square minus g square. H into f square minus g square is equal to 0. Here sides are equal. In the sides are equal, but angle between adjacent sides are does not perpendicular to each other. Square adjacent angle between is 90 degrees. All sides of the quadrilateral are equal. So this is the square. Now here these two conditions holds. The quadrilateral is a square formed by pair of lines. One, ABCD a rectangle. ABCD is a rectangle. Is a rectangle. If here also we have to observe, in that the first a plus b equal to 0. Angle between any two adjacent sides is always 90 degrees, but all sides are opposite sides are only. Now here clearly we have to observe a minus b into f square is not equal to 0. It is not equal to 0. In that, but all sides are not equal. But angle between necessary 90 degrees because of lines that are clearly perpendicular to each other. Then that quadrant is called a rectangle. The fourth condition, parallelogram. ABCD is a. In that, first of all, we have to observe the adjacent sides are less. That pair does not parallel to each other. B is not equal to 0 condition. Similarly, not equal. So clearly we have to observe the second condition here. F square minus G. The two conditions are not equal to 0. That is parallel. Equal 0. That means perpendicular holds. A plus B equal 0. Fg plus h and f square minus g square is not equal 0. Compulsory the perpendicular condition holds and all sides are equal. That means Fg plus h and f square minus g square is 0. But A plus B not perpendicular. So angle between any two adjacent sides is not to 90. Similarly, the sides are equal. E plus h and f square minus g square is equal to 0. So these are four terms. Similarly, this is quadrilateral form. So here to find area of the parallelogram. So area of the parallelogram. Area of parallelogram. Given two pairs of equations, then to find is mod c by 2 into square root of x minus a. So this is area of the parallelogram. The formula is mod c x square minus ab. Similarly, the next give two pair of lines to find diagonal equation. Diagonal line equation of but does not. Here we have to observe equation of diagonal. Clearly, now given two pairs of lines. In that, to find diagonal equation, here s equals 0 from s dash equals 0. Right, s equals 0 from s dash equals 0. Equation of diagonal. We get equation of diagonal. We get diagonal formation. Yes, difference between s dash and s is s dash minus s equal to 0. In that we have to observe ax square cancel, 2hx square cancel, by square cancel. Only five constant terms are there. That means 2gx plus 2fy plus c. This is the equation of diagonal. Similarly, so clear constant is there. Therefore, this diagonal does not pass through. Next, diagonal passing through. Suppose equation this is does not passing through origin. Does not pass 0 0. Does not pass. In that one, equation of diagonal passing origin passing through 0 0. Here we have to take, suppose this is xy plane. In that, this is one pair, another pair. So equation of diagonal does not pass is 2gx plus 2fy plus equal. So this is 2gx plus 2fy equal to 0. That means s dash yes or s minus s dash equal to 0. So here another diagonal is also there. In any quadrilateral, diagonals are there. One in the first diagonal is does not passing through the origin. The second diagonal is clearly passing through the origin because of one pair is completely passing through the origin. One pair of lines completely passing through. That means point of intersection of one pair is 0. So here clearly we have to observe diagonal clearly passing through origin 0, 0. That equation is hf minus b, hf bg into y minus bg equal to gh minus f into x minus af into y equal to gh minus af into x. Origin, this diagonal passing through the origin does not passing through the origin. In that constant is so these are similarly so here two pairs of straight lines. Now that two pairs form a parallelogram. Here one pair is given. One pair is given. Also one, so d equals to x plus m plus n equals 0. One pair of adjacent sides. This is one diagonal through the origin. Here another diagonal of the quadrilateral is in that the quadrilateral parallelogram. Here we have to observe this Lx plus s equals 0. This combined. Now here one diagonal is given and another diagonal clearly does not passing through the origin. That required diagonal does not passing through the origin. Now in that BL minus HM into y, BL minus HM into y equal to AM minus HL into x. AM minus HL into x. So here BL minus HM into y equal to AM minus HL into x. So this is second diagonal. This is second diagonal. Pass through origin, pass through 0, 0, pass through 0, 0. One pair is given and one diagonal is given. Now another diagonal. Now clearly the passing through origin and one diagonal of the parallelogram. So the other diagonal is BL minus y equal to AM minus HX. So this is one formula. Here we have to observe, given one point x1 y opposite vertex of a parallelogram square plus 2hxy plus b has one pair of equation of other does not passing through the origin. Equation of diagonal not passing through the origin is s1 minus s11 equals 0. Here 2s1 minus s11 equals 0. So this formula is, here one pair is given, here pair, and also one opposite vertex will be given, opposite vertex. So this is the opposite vertex. This is y1. This is x1, y1. Now in that we have to observe one pair of sides will be given. The equation of diagonal does not passing through the origin. Find the equation of diagonal does not origin. So this diagonal does not passing through the origin. So here to find that diagonal is 2s1 minus s11 equals 0. Here we have to take 2s1 minus s11 equal to 0. This is one formula is there. Similarly, the pair of lines. So this is 7th one. This is 8th one. Given the which can be formed as xy plus ax equal to x plus dy, xy plus cx plus dy plus cd equal 0. These two pairs form a square. That means a square. Form a. So this is one pair. This is xy plus ax plus by plus 0. This is so cd equal to given. Then here conditions. Now the first condition, if difference between a and c mod equals to mod b minus d, mod a minus always equals b minus d, and this is the condition, and a minus c into b minus d, mod a minus c into mod b minus area product of mod a minus c and mod b minus d, and point of intersection of diagonals, point of intersection of diagonals equal to point of intersection of diagonals equals to